Today we're in Chapter 2, Section 3, talking about multiplying and dividing numbers in scientific notation. Now we've done the adding and subtracting. Now we're going on to the other two operations, multiplying and dividing. This is in your text on page 81 if you want to follow along, page 81. So, if you have learned how to apply the product of powers property and the quotient of powers property to multiply and divide integers with exponents. To multiply 7 to the 5th by 7 to the 2nd, you keep the base and add the exponents. To divide 7 to the 5th by 7 to the 2nd, you keep the base and subtract the second exponent from the first, or subtract the exponents. So you're going to use these properties when you're multiplying and dividing numbers in scientific notation. The product of powers property and the quotient of powers property. So example 1, multiplication in scientific notation. Let's work on this one together. An Olympic-sized swimming pool is about 5 times 10 to the first meters long, meaning 50 meters. And 2.5 times 10 to the first meters wide, or 25 meters wide. Find the approximate area of the water surface. Well, it's a rectangle. Area is length times width, right? So area equals length times width. I'm going to take that 5 times 10 to the first times 2.5 times 10 to the first. Well, I'm going to use the commutative property and multiply just the coefficients separate than the base 10 powers. So I'm going to separate them into coefficient times coefficient and base 10 but times base 10. 5 times 2.5 is 12.5. 10 to the first times 10 to the first is 10 to the second. Well, my answer is not in scientific notation. So I'm going to move this decimal to the left, which is like adding one more to our exponent of 10 to the second here. So I get 10 to the third, and I have 1 and 25 hundredths times 10 to the third. So the area of the water's surface, so I'm sabling, is about 1 and 25 hundredths times 10 to the third meters squared, or square meters. You could write that out if you wanted to. Number 2. The length of the Aztec Stadium in Mexico is about 1 and 5 hundredths times 10 to the second meters long, and 6 and 8 tenths times 10 to the first meters wide, or 105 meters by 68 meters. Find the approximate area. Again, area is length times width. So I'm going to take my 1 and 5 hundredths coefficient and multiply it by 6 and 8 tenths, and then multiply my powers. 10 to the second times 10 to the first. 1 and 5 hundredths times 6 and 8 tenths is 7 and 14 hundredths, a coefficient in scientific notation. 10 to the second times 10 to the first gives me 10 to the third. So that number is in scientific notation. So our sable, the area, you could say, of the stadium, is about, because it says find the approximate, I could write out the word is approximately. I'm going to say is about 7 and 14 hundredths times 10 to the third square meters. Or I could use my abbreviation, meters square, meters to the second power. Sentence answer box label. Example 2. I'm going to let you try this one on your own. The outer wall of a large tourist attraction in Cambodia is about 1 2/200 times 10 to the third meters long, and 8 times 2/200 times 10 to the second meters wide. Find the approximate area enclosed by the outer wall. So pause the video and try this one on your own, and we will go over this answer. Sable it. We will go over this answer in class. Example 3, now for division. So that was multiplying. Now we're going to use the quotient of powers rule here, and we're going to divide. The planet Mercury has approximately the mass of 3 3/10 times 10 to the 23rd kilograms. Mars has a mass of about 6 4/10 times 10 to the 23rd kilograms. How many times as great as the mass of Mercury is the mass of Mars? Is and of kind of helps me decide which one goes on the top. Because remember when we were doing ratios, is over of? I mean, and that does work here. So I'm going to put the mass of Mars in the numerator, 6 4/10 times 10 to the 23rd, because it's not always the bigger one goes in the numerator. In this case it is, 6 4/10 is larger, over the mass of Mercury, which we probably know is smaller anyway, 3 3/10 times 10 to the 23rd. So I'm dividing those. So I could break this up into the two parts that it is. So I could say, okay, 6 4/10 divided by 3 3/10 times 10 to the 23rd over 10 to the 23rd. Well, they have the same power here, same exponent. So dividing my coefficients, 6 4/10 times 3 3/10, I get 1 93/100ths. Repetent. Oh, round to the coefficient to the nearest tenth. So that's going to help me there. So that's 1 9/10. And 10 to the 23rd over 10 to the 23rd, well, that's times 10 to the 0. And 10 to the 0. Which equals 1, which is why I was thinking 1 there, times 10 to the 0, because, right, 23, take away 23 is going to give me 0. Keep the base, subtract the exponents. So answering to the nearest tenth, about how many times is great? Mars has a mass that is about, about 1 9/10. 10 to the 0 really means 1. I could write times 10 to the 0 or not. I could just say 1 9/10 times larger. Than Mercury. Because to me it seems silly to write times 10 to the 0. Just means 1. So Mars, yes, the red planet is larger by about, mass-wise, by about 1 9/10, not 1 9/10 times larger. The letter B, the second one here. The sun has a diameter of about 1 4/10 times 10 to the 6 kilometers. The moon's diameter is approximately 3 5/10 times 10 to the 3rd kilometers. How many times is great as the diameter of the moon, that's going to go in the denominator, is the diameter of the sun? So 1 4/10 divided by 3 5/10 times 10 to the 6th over 10 to the 3rd. So keeping the base and subtracting the exponents, I get 10 to the 3rd. 1 4/10 times 3 5/10 gives me the decimal 4/10 times 10 to the 3rd. Well, that answer is not in scientific notation. And we are going to always answer in scientific notation. So moving my decimal to the right one place is like subtracting 1 from my power on my base of 10. So I get 4 times 10 to the second, or about 400 times. So in my Sable, I could say 4 times 10 to the second, or I could say 400 times. I'm going to say 400. The diameter of the sun not some, the diameter of the sun is about 400 times as great as the diameter of the moon. Long Sable there. Okay. So 400 times greater the diameter of the sun. Example 4. I'm going to let you try this one on your own, and it is the last part of the video. So the Abraj Al Bait Towers in Saudi Arabia has a floor area of about 1.5 times 10 to the 6 square meters. Woo, very large area. The Palazzo, if you've been there in Las Vegas, it's a casino in Las Vegas, has an approximate floor area of 6.5 times 10 to the 5th square meters. So answer the question and give the answer in a Sable, and we will go over example 4 in class tomorrow.